Wallet setup. What is a wallet? Well, a wallet is a flat case or pouch that can be used to carry small personal items like paper currency, credit cards, identification documents, and other paper or laminated cards. Questions? All right, there's more. What is a Filecoin wallet? Okay, just as a traditional wallet holds your currency, usually in form of cash or cards, a Filecoin wallet holds your digital currency, Phil, in the form of a secret key. For all intents and purposes, the secret key is the money contained in the wallet. A traditional wallet controls the access to your currency in a way. We don't just give people the entire wallet. We authorize those transactions by opening our wallets and taking out the cash we want to give someone else. We don't give them the whole wallet. Same with the Filecoin wallet. We don't give people that secret key. We use the wallet to perform the transactions that we actually want to perform with the amount of Phil that we want to transact with. We use the secret key to store and access the Phil securely, and we don't reveal that key to anyone else. The two main forms of wallets that we use are hardware wallets and software wallets. They each have pros and cons, but they both give us the ability to store and access Phil. The hardware wallet is a physical device that stores the secret key. The secret key is never revealed outside of that physical device. It's considered the most secure way to store the Phil because it keeps the secret key essentially offline where no one can access it. The only way to access the key is to physically have that device and to know the passphrase on the device. Even then, we're not directly accessing the key, we're just using it through the device. It doesn't give us direct access to it. There's no way to get it out of the device. The key is actually stored on tamper-proof silicon in the device. If we try and retrieve it, it should be destroyed. It's just in there. With that level of security, it's less convenient to use the wallet because we have to connect that hardware wallet to a machine and enter that passphrase on the device. It's usually little buttons to press, and bring it online briefly by plugging it in every time we want to send that transaction. We can't just leave it on a server that's automatically doing it. We have to manually approve each transaction. But then that becomes a good option when we want to store large amounts of Phil, when we don't have to send those transactions out often, but we want it to be secure. You can still receive that Phil even when the wallet's offline. It doesn't have to be plugged in because the actual sending and receiving of Phil happens on the blockchain. So when the wallet's not plugged in, people can still send us Phil. Next time we plug it in, we'll see, yep, it's arrived there, and we can see without even plugging it in, we can see it's on the blockchain, arrived to our address. All those transactions stay on the blockchain. The only hardware wallet that supports Phil currently is made by Ledger, and it doesn't support Phil out of the box, but when we use a software tool like Glyph or Lotus Wallet, we can use the Ledger to interact with our Filecoin wallets. The other option, if we want to store Phil, is to use a software wallet. They can come in various forms. They could be an online exchange. They could be software we run ourselves, or a third-party app or website. So an exchange is a third-party site. We have to trust them with the keys to the wallet. But there's other online wallets available. In the case of using the Lotus software itself, the secret key is stored on the server that the Lotus install is running on. That's what's used to send the transactions. It's more convenient, but to secure that wallet, as it's not held in a tamper-proof piece of hardware, we need to use more layers of security to make sure no one gets access to that server because they could potentially access that key. When we're accessing wallets on third-party websites, we need to trust those websites. And we need to trust the exchanges we use because they could do something bad with our wallets. They're in the hands of someone else. If we want to be really secure, we just have them on our own software. If we do lose the secret key, we could lose all of the assets in the wallet. It's equivalent to just handing someone your whole wallet. They could just take your money. So you don't do that. You make sure that it's not exposed to anyone. you need a plan in place to make sure it's secure when you're using hardware and software wallets. So be careful of who can physically access the building the data's in, the data center you're using, the home if you have backups there maybe. Ledger devices, generally they're pretty secure, but you never know, there could be a problem that we don't know about that develops if someone's actually physically able to access one. So we should just generally make sure that that doesn't happen. There could be a potential attack vector, and have monitoring in place, maybe cameras or some kind of access monitoring, both online and offline, to see who's coming in and out of those areas, who logs in. Make sure your network is secure, especially if it's connected to the internet, so use firewalls, maybe even go as far as using zero trust architectures, next generation firewalls, whatever is most appropriate for your needs. Keep the servers and machines you're using up to date with software updates to just make sure you protect against the latest vulnerabilities. That's general good practice. And back up the keys somewhere secure, but make sure that's not introducing a vulnerability by being an easy way for someone to steal the keys. Typically, the wallet's made up of two separate parts. There's the private key, which is the secret key that we've talked about. That's what's actually used by the software to make transactions and access the wallet, take money out, send it somewhere else. It all needs the private key. Proves we have ownership of the wallet, and as such, that's what we need to secure. But we also need a way to accept Phil into that wallet. We don't give them the private key, because then they could do anything we can. So we need a way to accept Phil into the wallet without giving them the private key, because if they have the private key, they could do anything we can. They could take money out of our wallets. There's a corresponding public key associated with every private key, and we use the public key to let other people send Phil to us. The public key is derived from the private key, so it's a one-way function. Each private key has one public key. It's difficult to derive the private key from the public key. Well, very difficult, essentially impossible. It's as impossible as anything in cryptography is at the moment. Maybe there's a quantum computer coming up that can do it, but if that does happen, then the Filecoin network will be upgraded accordingly, so it's essentially not a concern. We can just consider it impossible to create the private key knowing a public key. That means no one can do anything they shouldn't do just with the public keys. We can give other people the public key to send Phil to us from their wallets into our wallets. And you don't need the private key to be online to receive Phil, because it just happens on a blockchain. People just need to know the public address. Then they can send you Phil. There's a couple of different ways to interact with the Filecoin network and manage the Phil. First is the Lotus wallet. So Lotus being software. It's a reference implementation of the Filecoin network. It's written by Protocol Labs. It's a command line interface. It's functional, but basic. It lets us do everything we need to do, though. Interact with Filecoin network. It does work with, well, it implements a software wallet. It works with hardware wallets. It contains a lot more functionality than that, but for wallet purposes, we can just use that as our wallet. We can also use Lotus to set up the Lotus node, which synchronizes with the rest of the network, and the storage provider node, which allows us to seal data, store data, compliance. Or we could use an external wallet, but be careful when using an external wallet, because external means, one, not run by the actual storage provider, so run by a third party. They have full access to anything you can do with your wallet, so you need to make sure they have done appropriate security audits, that they're reputable. Two examples with security audits having been performed on them, but there's more examples. So Glyph, it's a browser-based tool. You can interact with the Ledger hardware wallets to sign or send transactions. And Fox Wallet, it's a mobile app on Android or Apple devices that we can use to interact with the Filecoin network and send or receive transactions. They've been independently audited, and others are available, but any vulnerabilities in those would be a problem. Then cryptocurrency exchanges. Most people these days are probably familiar with just the general concepts of a crypto exchange. They're convenient. We can buy fill, exchange it from other currencies, from fiat currency, and store fill. Usually it makes it easy to access the fill as well, but just be careful about leaving significant amounts of assets on those exchanges, because there have been a number of high-profile incidents with currency being stolen from the exchanges. It's not in your hands if it's on an exchange. It's on someone else's hardware. Something could happen. It's a useful tool, but for the best security, use your own wallets, store locally, hardware wallet or Lotus wallet, because then you're in full control of the security. It's not up to a third party. But maybe it makes sense. It depends. Depends on the amount of fill you're looking to protect. So in practice, you'll use a variety of different wallets depending on the need, not just one. If we're looking for a more secure way of protecting what a wallet can do, we can use what are called multisig wallets, so-called because there's multiple signers, multiple signatures required to authorize any transaction. Different people, different entities can be given different private keys, and it's only possible to perform transactions with a correct number of those keys, meaning one person isn't just able to go rogue and take all the money out of the wallet. It requires multiple people to authorize anything. It's useful when it's difficult to ensure full trust between all the parties involved, because when we're using one single wallet with one key, then who gets the private key? How can we make sure that no one just takes that money and walks away? We can use multisig wallet, make sure no one person has that authority. It resolves the trust. Each party involved in the multisig wallet has their own key, they control their own key, and each person is called a signer. It'll take 2 or more signers to send the transaction from the wallet. When we create the wallet, we can specify the list of signers. We can have as many people as we need to be involved there. And then we specify how many of those are required to send a transaction to the network, so to be able to spend the fill in the wallet, essentially. It could be 2 people, it could be all of the people. It can't be changed after creating the wallet, but we could just create a new wallet if we want to change who's allowed to do what. In practice, the workflow for sending a transaction from a multisig wallet is that any signer can propose that transaction, goes into a mempool, waits on the network. Everyone else the different signers can see that, but they can approve the transaction as well, if they choose to. That happens, each person approves it until the minimum number of signers is reached, and then the transaction is completed, goes onto the network, the fill gets sent to where it should go. So it allows trust to be split out from that single wallet. If too many signers do lose access to their keys, then it would render the wallet inaccessible. If one person has a key, but you need 2 people to sign a transaction, then if one person has a key and everyone else has lost their key, then that's essentially it's lost all the funds in the wallet. So you've got to make sure that there are enough people with access to the keys and they don't lose it. Lotus is software built and maintained by Protocol Labs. It's a reference implementation of the Filecoin network. It contains the features to run a Lotus node, letting us interact with the network. Also run a storage provider node, and run a wallet to manage fill and the accounts, and more. It's a reference implementation. All the latest features on Filecoin network appear in Lotus. There's 2 running versions of the network we can join. There's mainnet, which is the real version of the network. If we create wallets on mainnet and spend fill on mainnet, it's real money, and if we're doing testing, we may not want to use that. So for that purpose, there's a separate network called CalibNet, and it's a test network. We can essentially play money on the network. We can test things out, send fill around, and it's just test money. It doesn't have any significant value. We don't have to worry about it. The mainnet network addresses get prefixed by F for Filecoin, and T is on the testnet with CalibNet. I mean, it's called CalibNet, but it's prefixed with T for testing. That's just how it's arranged. There's different kinds of addresses that you'll see on the Filecoin network, so let's just go over each one of those briefly. First address you'll see is prefixed by F0. It's an identity address. It's meant to be more human readable because it's a lot shorter than other forms of addresses. One example, F033259. You could read that back to someone. Each of the shorter addresses is tied to a longer public key address behind the scenes, but we see the shorter address. We can just use it as the full address. And they're linked to individual storage providers. Next address is the F1 type of address. It uses the SecP256K1 signature in cryptography. Not too important to understand what it is, but that's what it uses. It's able to validate messages from other blockchains that use the same signature, such as Bitcoin. You can derive the public key from the signature, which means that the blockchain doesn't have to store that public key when you make transactions, and that saves space. That translates to lower fees. So it's a good idea to use an F1 address if you don't need anything else. If you do need something else, you might be interested in the F3 address. It uses the BLS signature instead. There's benefits to using this address. It's deterministic. For a given message and key, the signature is the same. It increases security against common blockchain vulnerabilities. You can aggregate multiple signatures from signers into a single signature, which saves space on the blockchain with the condensed signature. But it does consume more space on the chain when you're using it for things it doesn't really need to be used for. You can see in the example of that F3 address, it's quite long. So it just takes up more space in messages. And associated fees are higher, but it's necessary to be used in, for instance, the storage provider's worker address that's dealing with storing data. It needs to be an F3 address for that, for the features it provides. Then there's the F2 address for actors on the Filecoin network. Those are specifically defined in the Filecoin spec. It defines types of actors, like a storage provider, clients, different actors. They're essentially smart contracts, as would be understood on other blockchains. They have certain abilities. They're controlled by the blockchain. No one has a private key for them. They just live on the blockchain and they perform actions that are predetermined. Such as the Multisig Wallet as well, because it's not controlled by one single person. It's an F2 address. It has multiple signers. It's essentially a smart contract. It just lives on the blockchain. Then the different roles of wallets. The first and most important specific wallet with a role is called the owner wallet. The owner address. It's a wallet that controls the storage provider node. It has a lot of power over the storage provider node. Any balances on the storage provider node that we withdraw go into the owner wallet. You need access to the owner wallet in order to change to a new owner wallet. And you want to protect it because it has full control over the storage provider. You should isolate it from the rest of the network, limit access to who can use it, have backups, keep those backups secure, maybe keep the private key on a hardware wallet because it's got full control of the entire storage provider. At this time, unfortunately, the owner wallet can't be stored in a hardware wallet or a multisig wallet, which is really what we'd like to do for security. The most secure or the most vulnerable key can't be secured on a hardware wallet, but it's not a feature that's being worked on. You can see issues on Lotus's GitHub to see progress. It's all public, and certainly a lot of people are interested in gaining that functionality. The next wallet is the worker wallet for day-to-day tasks from the point of view of a storage provider. So it sends messages to say we have proofs available, terminating sectors, the process by which we prematurely discontinue running a sector. We can signal to the network if we lost a sector, for instance, somehow we can tell the network, okay, we need to terminate that sector because we don't have it anymore. We'll incur a lower fee that way than if we just don't tell the network that we've lost data. We try not to, but if we do, well, that's that wallet would send that message. And if we make a deal, client makes a deal, then as a storage provider, that wallet would send a publish storage deals message. All the funds for those transactions come from the worker wallet. When the storage provider needs fill for those kinds of messages or for the pledge collateral put up when you're sealing data, it'll take it from this worker wallet unless there are specific speciality wallets that are dedicated to certain purposes, which we can talk about next. We can split out those responsibilities from the worker wallet because of the head of line blocking problem inherent in the queue system used on the messages on the network. It's impacted by congestion. There's many types of messages sent to the blockchain. Some are more time sensitive. When we're sending proofs of successful sealing of data, well, we have to send that proof in a certain period of time. But when we send other messages, there's no time limit. So we may want to spend more on the gas fees for the more important messages. But when we're sending messages from a wallet, they're processed in order. If the important message gets stuck behind a message that's not as important, it can delay that important messages from getting through. So we would then look at using separate wallets that have their own dedicated purpose to make sure nothing important gets delayed. It can have its own separate wallet. And really, you can just think of it as lanes on the highway. Separate lanes, send the messages down their own lanes. If there's a car stuck in one lane, well, okay, no one's moving over in the Filecoin analogy here. Everyone will just stay in their lane and just wait until it goes away. You open up the separate lane so you can send the fast messages down that speedy lane. So more about congestion. The Filecoin network can get busy when there's a lot of transactions occurring. The same way we experience rush hour on the way home from work, messages can get delayed during busy times. Normally it's not that big a deal, but there's one specific messages that's really time sensitive for the storage provider to send, and it's the daily audit message called window post, window proof of space-time. We've got to send that within 40 minutes every day for each piece of data. And it's got a lower cost, but if it gets stuck behind other messages in a worker wallet, then it gets blocked, and if it takes too long, we would then have penalties incurred that we didn't really need to. So we create these separate lanes to avoid that congestion. The solution, these separate lanes, are called control wallets. You can see on the slide an example of a control wallet to send your proof of space-time messages down in that speedy looking car. While the other boring mundane messages they can wait, because it's no big deal if they're delayed. We need the post message to go quickly. We use control wallets. We split out into as many wallets as required, it depends on the storage provider's needs. Generally though, we're looking at proof of space-time wallet, pre-commit message wallet, part of the sealing process commit wallet. Again, part of the sealing process, but maybe there's different fees attached to that, so you may want a different wallet to have different requirements. Publish message for client transactions. If you want to make sure they get on chain quickly, you may want a separate wallet. And terminate wallet, if you're signaling to the chain that you have lost data, you can send it separately that way, because it may be important that you do that quickly. So as we can tell, there's a lot of different considerations to make when we're storing and managing the fill. A lot of different ways to do it. Each way has its own benefits and its own drawbacks. But generally, the community's found that best solutions include a variety of different wallets, taking advantage of the strengths and weaknesses of each one, depending on the use case. But we must always remember that security is the most important takeaway here. If anyone gets the private keys, they have access to the funds. We have to protect those private keys. It's the worst case scenario, and we must do everything we can to prevent it. That being said, it's perfectly secure to use the network. Just have to keep that in mind, just as we wouldn't just go and give someone our wallet in real life.